Today we're going to look at relations. A relation defines a relationship between two sets. It associates elements of a source set, called the domain, to elements of a target set called the range. In a given relation, we say that a domain element corresponds to the range elements that are associated with it. Relations are frequently encountered when you're working with data. For example, you may have a relation that associates an athlete's name with scores that they earn in a competition. This chart of values defines a relation in which the name Maria is associated to the score 8, the name Laura is associated to the scores 9 and 5, and the name Khadijah is associated to the scores 10 and 8. The domain of this relation consists of all of the elements of the first column, which are the names, Maria, Laura, and Khadijah. And the range of this relation consists of the elements of the second column, which are the scores 8, 9, 10, and 5. Note that it doesn't matter which order the correspondences are written in and which order the elements of the domain and range are written in. For example, if I go ahead and add another row to our chart of values that associates the name Maria to the score 8, this does not change the relation at all because the correspondence of the name Maria to the score 8 was already part of the relation. Similarly, if I were to write a domain element twice, so if I were to add, say, Laura again to the domain, or if I were to add 8 again to the range, this doesn't change the domain at all because Laura was already listed as a domain element and 8 was already listed as a range element. It also doesn't matter what order the correspondences of the relation are written in or what order the domain and range elements are written in. I could move the correspondence of the name Maria to the score 8, and this doesn't change the relation at all. Similarly, if I were to write the domain with Laura first, and then Khadijah and Maria, this is the exact same domain. This does not change the domain at all because the order of the domain elements do not matter. Similarly for the range. Charts of values are one common way of writing finite relations, by which I mean relations where there's a finite number of correspondences and where the domain and range are finite. But there are some other common ways to represent relations like this. Another common way to represent a relation like this is as an arrow diagram. In an arrow diagram, we list the domain elements together and we list the range elements together, and we draw an arrow to represent each correspondence. So to write our example of athletes and their scores as an arrow diagram, we'll write the names, which are the domain elements, in one column, and we'll write the range elements, which are the scores, in another column. And then for each correspondence or row in the chart, we draw an arrow from the name to the associated score. So we get an arrow from Maria to the score 8. We get an arrow from the name Laura to the score 9. We get an arrow from the name Khadijah to the score 10. We get an arrow from the name Khadijah to the score 8. And we get an arrow from the name Laura to the score 5. Note that I only needed to write each domain element or name once and each range element or score once, and that it doesn't matter which order the domain elements are written in and which order the range elements are written in, so long as I have an arrow for every correspondence or row of the table. Another common method of representing a finite relation is as a set of ordered pairs, where each pair defines a correspondence from its first coordinate to its second coordinate. This is how we write our example of athletes and their scores as a set of ordered pairs. Note that the correspondences, which are the rows from the table or the arrows from the arrow diagram, become the ordered pairs in this notation. Note that the domain is the set of all the first coordinates of the ordered pairs, and the range is the set of all the second coordinates of the ordered pairs. So here you have the definition of a relation and its domain and range, and how we can define relations using charts of values, arrow diagrams, and set of ordered pairs. And it's important to be able to translate between these three ways of defining a relation, as well as to determine the domain and range from each.